All right, this is modeling with linear functions, part 2. So we're going to be looking at example 3, finding a line of fit. The table shows the femur lengths in centimeters and heights in centimeters of several people. Do the data show a linear relationship? If so, write an equation of a line of fit. Use it to estimate the height of a person whose femur is 35 centimeters long. All right, so you can see that they give us a table here, the femur lengths in centimeters and your height in centimeters. All right, so the first thing it says, do the data show a linear relationship? So we're going to take our calculator and we're going to enter this information in our calculator. So let's see if I can move this over here a little bit. All right. Let's clear the last equations out. All right, if I want to enter a table, I'm going to go to Stat and Edit. So hit Enter. All right, I'm going to put all of the X's in L1, all the Y's in L2. I'm going to pause the video for just a second so that I don't waste time, but I want you to do the same thing. If you have a TI-84 or an 83, please go to Stat and hit Edit and put this table in your calculator. All right, once you have your table of values entered in your calculator, you should always double check those, make sure they are correct. If you have something typed in correctly, it is not going to give you good information. So make sure you do that. Once it's in here, you do second mode, that's quit. So once you quit, it saves that table in there for you, but now you don't have to worry about it until the next time you need it. It will generate it for you. So we need to do a scatter plot. So we're going to go to second Y and we're going to turn on stat plot. All right, this shows me that I'm going to have a scatter plot right here. So I hit enter, and then when I hit graph, it should show those points on there. Now you can see that this window is still from the last graph. So let's see, we need to go up through about, our X's need to be up through, let's say 55. So we're going to make this a little smaller because, let's change this to 5 instead of 10. All right, and we don't need to worry about our minimums. Our maximum Y value, we can see this goes to 195, so let's say 200. And then we're going to change this, say, to tens. Changing your scale just means like in the window, typically you go by ones, but when you have numbers that large, you may want to do it a little different. All right, so this gives you your scatter plot. That's the points in the table. Now they're here on the graph. So that's what it looks like. Now, so it says the table shows the length of femurs and the heights of people. Do the data show a linear relationship? All right, it kind of looks linear. I mean, you could say that looks, you could draw a line between those points. So we're going to say yes. And then it says, if so, write an equation of the line of fit and use it to estimate the height of a person whose femur is 35 centimeters long. All right, so let's go ahead and turn on our correlation coefficient. If you do second catalog, all right, second catalog, go down to diagnostics. You may be able to hit D. I always just scroll down through here, but go to diagnostics on. What this does is turns on, when you turn on the diagnostics, now it's going to show the R value. Hit enter twice, so it says done. Now when I create an equation, it's going to tell me the correlation coefficient, which tells me how reliable or how close that equation is to being a good fit. So let's go back to stat. This time, instead of edit, remember we've already put our table in there, so this time we're going to go to calculate. Oh, I hit the wrong one, sorry. Go back to stat, calculate, and I need to go down and do a linear regression because we're trying to make an equation of a line Remember, a line is linear. I think I just hit number 1 before, but we need number 4. All right, so if we do number 4, it's going to pull from our L1 and L2 list, and then just enter through that so it will calculate. So that's going to give you a linear equation where your slope is 2.6 and your y-intercept is about 65. And this says R is 0.99. Well, that's very close to 1. So if you remember, that means it's a very strong correlation. So we're going to say y equals 2.6x plus 65. All right, now if you didn't have a calculator, you could still use 2 points to find your slope, and then you could use one of these points to write an equation in point-slope form like we did in the last example. But if you have a calculator, it's very fast and easy to do it using your calculator. All right, so write an equation to find the line of fit and use it to estimate the person's height when they have a femur is 35 centimeters long. So your femur length is your x value. So what we need to do is plug that in. Y equals 2.6 times 35 plus 65. All right, so I'm going to say 2.6 times 35 plus 65 and hit enter. So that would say the height is 156 centimeters. So y equals 156. So that would be in centimeters. You can see the y value is the height of the person. So the approximate height of the person whose femur is 35 centimeters long would be 156 centimeters. All right, this is the last part of this assignment. So I want you to do a self-assessment. First one is a vocabulary term. A line of best fit has a correlation coefficient of negative 0.98. What can you conclude about the slope of the line? Right, you can go back in your notes. You could Google correlation coefficient. However you want to find the answer to that, please do so. Hopefully you already know what the answer is, but if you don't, look it up. All right, number 2, the data pairs represent the humerus lengths x in centimeters and height y in centimeters of several females. All right, instead of a table, they're giving you ordered pairs, but that's the same information, just in a different form. So it says, do the data show a linear relationship? If so, write an equation of a line of fit and use it to estimate the height of a female whose humerus is 40 centimeters long. All right, take a few minutes, work on these, pause the video, work on these yourself, and then come back to see how you did. All right, if you did the self-assessment, hopefully you found that the correlation coefficient of negative 0.98, it is a linear because it's line of best fit. So it talks about a line, so we know it's linear. And we know it's going to be a strong negative correlation because it's close to -1. And then for number 2, yes, the data points show a linear relationship. If you took these points and plugged them into your calculator, you should have went to Stat, Edit, and then went back to Stat, Calculate, and done linear regression. You would have got an equation close to this. And then you could plug in 40 centimeters into your x value here, and you could conclude that the height of a person with a humerus of 40 centimeters long is about 188 centimeters. All right, that's all for modeling with linear functions.